I am Anil Kumar, sharing with you a set of 5 questions which will help you understand the key concepts of exponential functions. This will prepare you for your own test on the unit for MCR3U grade 11. I'd like you to pause the video, copy these questions, answer, and then look into my suggestions. Question number 1 is, what are the restrictions on the value of n in b to the power of 1 over n if b is less than 0? Question number 2 is, describe the transformation of f of x equals to minus half 3 to the power of 2x plus 4 plus 5. What is the domain and range of the function? Question number 3. What is the decay rate in the equation p of n equals to 75 times 0.88 to the power of n? Question number 4. Internal temperature of a tandoori chicken is modeled as T of t equals to 63 times 0.5 to the power of t over 10 plus 19, where t is the temperature in degrees Celsius and time t is in minutes. A. What is the initial temperature of the chicken? B. How much time did it take for the chicken to reach an internal temperature of 30 degrees Celsius? Last question here is, a town has a population of 8,400 in 2000. 15 years later, population grew to 1,500. Determine the average annual growth rate of this town. So I hope the questions are absolutely clear. I'd like you to solve them first and then look into my suggestions. So let's solve them now one by one. Question number 1. What are the restrictions on the value of n in b to the power of 1 over n if b is less than 0? So let me write down the expression. We have b to the power of 1 over n, right, where b is less than 0. We need to find restrictions on n, right? So we need to find restrictions, and n also means domain of this function, right? So we could write this function as f of n equals to this. So I hope the question is absolutely clear. Well, as some of you have already seen, n should not be equal to 0, right? Since 1 over 0 is infinitely large quantity which is not defined, right? So 1, n is not equal to 0 is perfectly fine. What else? b is less than 0 means what? So when I say b is less than 0, that means b is negative, right? b is negative. Now, this is an exponential function where b is negative. What could be the restriction on n? Think like this. Can you have square root of minus 2? No, right? Do you get an idea, right? So that tells you that n should also be odd integer. You get an idea. So n cannot be even because square root of or even powers of radical sign for negative values of b are not defined. You get an idea, right? And therefore our answer is that n is not equal to 0. So that is the first restriction. The second one is that n is odd. It's an extremely important question which I've seen in test papers sometimes, but very few students are able to answer this question. I hope you understand and appreciate it. Now let's look into question number 2. Straightforward knowledge-based question. Describe the transformation of the function f of x equals to minus half 3 to the power of 2x plus 4 plus 5, right? Now that should be simple. There is not much difficulty in answering this question. So let's write down the points about its transformation. It is important to note that whenever you have given a function in this form, you should rewrite it first. You haven't done so. In that case, you run into risk of writing a wrong answer. Let me show you how. So we have 3 to the power of what? Factor 2 out. Once you factor 2 out, you get x plus 2 here. Do you get an idea? Now the horizontal translation has changed. It is not 4 units left, it is 2 units left. That's a key thing to understand, and that could be a mistake for some of you, right? So now it's very easy to write down the transformation. What we have here is base function is, let's say g of x is 3 to the power of x. So all the transformation which we are going to describe is with respect to 3 to the power of x. It is important, not necessary, however, very important to mention this when you write transformations, because that has not been mentioned in the question, right? Okay, so I hope it makes sense. Now let's start from left side. Minus means reflection on. These are y values, so it is a reflection on the x-axis. Okay, now here 2 means everything inside this bracket relates to horizontal. So it means horizontal compression by a factor of half, right? So it gets divided by 2. I purposely missed this. So let's get back to the vertical compression by a factor of half, which is outside, right? So the outside is vertical compression by a factor of half. So this is because of this half, right? Now we can write translations. You can combine both the translations together. So you can say translate 5 units up and 2 units left. Perfect. So that is how you are going to describe this particular transformation. Now what I would like you to do is sketch this graph, right? So let that be an exercise as question number 2b. Now in question number 3, I have added another component to it. So we'll do question number 3a, which is what is the decay rate in the equation P of n equals to 75 times 0.80 to the power of n. Let me rewrite the equation. It is Pn equals to 75 times 0.80 to the power of n. Well, I just changed this question. It was 88 in the original question. I just made it 80 here. Okay. So we are talking about decay rate. Why? Since this number is less than 1, so definitely we have a decay, right? Now 0.80 is a decay factor. So let me write down decay factor. Decay factor is 0.80. We want decay rate. Do you understand? Decay rate. What is decay rate? So for that, you should rewrite this equation as 75 times 1 minus something, right? So 1 minus 0.20 to the power of n. In that case, this factor, this part of the factor 0.20 is your decay rate. Do you understand? So decay rate could be written as 0.20 or 20%. You get an idea. So you have to write this part as 1 minus what? So every time it is decaying at the rate of 20%. That is what it means. I hope that's clear, right? Now with this concept, I'd like you to answer 3b, which is, what is the growth rate in the equation an equals to, let me rewrite this equation here, an is equals to 100 times 1.02 to the power of n. Following the concept just learned, we could write this as 0.02 to the power of n. So it is definitely a growth, right? This factor is more than 1. But what is the growth rate? Growth rate is 0.02, which is 2%, not 20, 2%. Do you see that? So at times you may just write quickly 20%, which will be incorrect. So I'd like you to, think about it. And now let's move on to question number 4. Here is an application and thinking question. Question number 4. Internal temperature of a tandoori chicken is modeled as T of T equals to 63 times 0.5 to the power of T over 10 plus 19, where capital T is the temperature in degrees Celsius and time T is in minutes. What is the initial temperature of the chicken? Part B is, how much time did it take for the chicken to reach an internal temperature of 30 degrees Celsius? So let's do part A. When we say initial temperature, it means time t equals to 0. Is it okay? So let's figure it out. So if I substitute small t, lowercase t as 0, I get the temperature to start with, t equals to 0, is 63 times 0.5 to the power of 0 over 10 plus 19. Now anything to the power of 0 is 1, right? And therefore what you get here is 63 plus 19 as your answer. So that is your answer, correct? So the temperature, initial temperature is 63 plus 19. 9 plus 3 is 12 to 1, and that gives you 6, 7 and 1, 8, 82 degrees Celsius. That becomes your answer. Perfect. Now let's do part B. In part B, how much time did it take for the chicken to reach an internal temperature of 30 degrees Celsius? So we are given capital T this time. So we'll write capital T equals to 30 degrees equals to 63 times 0.5 small t over 10 plus 19. You have to find this lowercase t, time in minutes. How are you going to find it? So it is an extremely important exercise. I like your attention to understand this, and if you may have to kind of remember a formula, okay? So first, let us rearrange so we can get this as 30 minus 19 equals to 63 times 0.5 to the power of t over 10. Now, let's use the calculator. Okay, 30 minus 19 is equal to 11. So we get 11 equals to 63 times 0.5 to the power of t over 10. So now we are going to divide by 63. So 11 over 63 is equals to 0.5 to the power of t over 10. Okay, so what is 11 divided by 63 equals to? In decimals it is, okay, let's keep it 11 over 63. Okay, how do you find time from here? That's a huge problem, right? Now some of you might know about it. We will use logarithmic functions to find this answer. Okay, so the concept is kind of like this: take log both sides. So the steps are take log both sides. So if you take log both sides, you get log of 11 over 63 equals to, so using properties of log, this exponent could be written as t over 10 log of 0.5. Do you see that? So that is the property of log. Now I know some of you have not learned this, but these are critical steps to learn now. Now from here we can divide the left side, which is log of 11 over 63, by log of 0.5 to get t over 10. So t is how much? T will be equals to 10 times log of 11 over 63, right? Put it in brackets, divide by log of 0.5. You get an idea. So that is how you can get the answer. Let's do it. So we'll do this part first. Log 11 divided by 63 bracket close divided by log of 0.5 equals to, and we are going to multiply this by 10 to get the time, which is 25.17 minutes, right? So approximately we can write down that the time is t equals to 25 minutes. Do you get it? So this is the best way of solving. Otherwise, you can do trial and error. Just keep on trying the values of t. You might get 25 as your answer. Perfect. However, this technique has not been explained, sometimes not explained. So I'd like you to make a note of this. How to use logarithms to find the exponent value when solving exponential functions. So I hope that's clear. So take some time, understand, and move forward to question number 5. Here is the last question from my set of 5, and I hope you understand and appreciate that we have covered all type of things which you should know in this particular unit of exponential functions. We have also seen how logarithmic functions can be used to calculate the exponents. Now in question number 5, we'll learn the last technique, that is how to write the exponential function for any given word problem. So now the question is, a town has population of 8,400 in 2000. 15 years later, population grew to 1,2,500. Determine the average annual growth rate of this town. So in this particular question, we have not given you the equation. So you have to define the variables, write down the equation, and then find the growth rate. Perfect. What we know here is initial population of 8,400 in 2000. And after 15 years, the population grows to 1,2,500. So let us say P is population. After t years, okay. So we could write this as population as a function of time equals to initial population and 1 plus growth rate to the power of n, where well, I use t, so I'll use t, right, to the power of t, since it is t years. So that becomes your exponential function, which can describe the given situation. Now here, initial population is 8,400 and the population after 15 years is 1,2,500. So we can write when t is equal to 0, initial population is 8,400, right? And when t equals to 15, then population 15, I should write here, P15 is equals to 1,2,500. So let's put these conditions in our equation. So we have 1,2,500 equals to 8,400, 1 plus r, that is the rate which we need to find, to the power of 15. You get an idea, right? So at t equals to 15. Now we have to find r. You can now pause the video, answer the question, and then look into my suggestions. So to find r, will divide by 8400. So we could write this as 12500 divided by 8400 equals to 1 plus r to the power of 15. Of course, you can simplify this, but I'm not doing so that you can see all the steps very clearly. Now we'll take the 15th root, right? So 12500 over 8400, and we'll take the 15th root. That is 1 plus r equal. Perfect. So what is r equals to? Now you know it, right? You can definitely solve this equation. And let me write down the answer as r is equal to, now from whatever you get, it'll be like minus 1, right? So it is 15th root of 12500 divided by 8400. Take away 1. So that gives you the solution. So all such questions will be solved in this particular method. So this is your general method to solve such question. So we learned in question number 4 how to use logarithms, and here how to find the growth rate or even depreciation rate or decay rate in the similar fashion. Okay, let's now calculate it. So we are looking for 15th root of this. So let's do 12500 divided by 8400 equals 2. And now we'll do power of this. So whatever we get, power of 1 over 15 we'll do, right? So divide 1 by 15 in the exponent, we get the value. So which is, let me write down, 1.0268 minus 1. So we get r as 0.0268, correct? So that is the growth rate in decimal values. In percent, you can multiply by 100, right? So this is the decimal equivalent. In percent, you have to times this by 100, correct? So when you times this by 100, you get 2.68, or you can say 2.7%. Does make sense to you? So our answer is rate of growth is 2.7%. So I hope you understand and appreciate what we have done and how we selected these 5 beautiful questions to cover all the concepts which you should know on exponential functions. Feel free to write your comments and your suggestions. And if you like, subscribe and share your views. That'd be great for me. Thank you and all the best.